Hello everyone, welcome to our first recorded lecture for labor economics, and thank you so much for taking the time to join me. I really can't wait to talk to you on Zoom about the stuff we'll be going over today. So before I dive too deep into this lecture, I want to take a minute to talk about what my goals are for today. And I really have two objectives here. The first is to spend some time exploring this paper that I had you read, The Race Between Education and Technology. And the reason I chose this paper in particular, the reason I'm excited about talking about this paper, is I think it does a very nice job of capturing really everything we're going to try to accomplish in this class. It takes a simple economic model, figures out a way to test its implications against real-world data, and then uses that connection between the model and the data to make some pretty sweeping and pretty striking claims about the underlying mechanisms driving inequality in the United States over the last several decades. So this is really what we're going to be focusing on through a lot of this class, is understanding how to connect our economic theory to real-world evidence, and then thinking about how to interpret that. Now, the other thing I want to do today, though, is to use this paper as a launching off point to think carefully about regressions and about empirical evidence. So as you guys know, we're not requiring econometrics in this class, and I'm not going to spend any time during this class asking you to think about things like standard errors or normality assumptions or other technical details of regression analysis. That's all stuff that you'll cover in econometrics or have already covered in econometrics. What we're going to do in this class, though, is to think very carefully about what we can and can't learn from empirical evidence, in particular from linear regressions. So that means we will think about how to interpret regression coefficients, but more importantly, we're going to think about the relationship between regressions that tell us about real relationships, observed relationships between pieces of data in the world, and underlying causal mechanisms, underlying stories about how the world works, how different stories about how the world works will generate different empirical evidence. Okay, cool. Now, what this paper is primarily trying to accomplish is trying to understand changes over time in the college earnings premium, which is the difference in earnings between college graduates and high school graduates. Right, so we've got this simple thing here. We're defining it as the college earnings premium. It's going to be the average earnings of college grads minus the average earnings of high school grads, which they're going to understand as essentially representing the benefit to a worker, right, the extra productivity to a worker of going to college, of becoming educated. So the first thing I want to do is to actually complicate this a little bit in order to help us think about how to interpret this difference and how to use the tools of regression to do so. So to begin with, let's recognize that in the real world, while we can calculate the average earnings of college grads, the average earnings of high school grads, each individual is going to have a different level of earnings than each other individual, right? In other words, if we wanted to, we could draw a graph where we've got years of school, right? So we've got, let's put 12 for high school grads, 16 for college grads. We've got earnings, right? Let's say 50,000, 100,000. Right, and even if we have an actual average earnings for high school grads of, let's say, 30,000, right, this is the actual average, there's going to be some individuals who earn a lot more than that. There's going to be some individuals who earn a lot less than that, right? So we can imagine that each of these dots on the graph represents a person. This big dot represents the average for the whole education group. And likewise, right, for college graduates, we have an average earnings for college graduates of, let's say, 70,000, just making things up, right? So we've got an average here. We're going to have some people who earn a lot less than that, some people who earn a lot more than that, right? This will be the average for the group. And our college earnings premium is going to be the difference between these two averages, right, which is going to be 40,000. Great. Now, one way to think about this, one way to understand these averages, is as essentially what you guess someone's earnings to be if all you knew about them was how many years they spent in school, right? So we could say that someone's actual earnings are going to be our guess for their earnings, which is going to be the average earnings, right, plus some error term, right? So this is going to be the guess. This is going to be how wrong they are for that particular person, right? Why is this the guess? Why would we guess the average? Well, because anything else, right, if the average is 30,000 for high school grads, if we guess lower, we'd be wrong more often than if we guess right at the average. Great. Now let's imagine that I wanted to guess how much someone earned who had 14 years of school, right? I knew that high school grads earn 30,000 on average, college grads earn 70,000 on average. How about someone who spent 2 years in college, right, got an associate's degree? Well, one reasonable thing to do would be to guess the average of these two numbers, right? So to guess that that person's going to earn about 50,000. Right, we might not think so. Some people might think, no, it'll be less. Some people might think it'll be more. But if we don't know very much about how education works, this might be a reasonable assumption. So what we'll be doing here is essentially assuming that each year of education changes your earnings by the same amount, right, or has the same relationship with earnings. So instead of just guessing the average based on the number of years you spent, we might want to say that our earnings are going to be A plus some slope times the years you spend in school plus an error, right? So this is going to be our slope, right? The amount that your earnings change in each year. Right, and this is going to be the amount that you earn with no school. Right? So effectively, this is doing exactly the same thing as our strategy of guessing the averages. It's just in this case, instead of guessing the average based on the number of people with exactly the same amount of time in school, we're kind of getting an average relationship between these two things, right? Our earnings and our years of school. So if we filled out our graph, we included in here people who had less than 12 years of school, right? Let's say people who dropped out of school in 10th grade, people who stayed in school through college, maybe even people who stuck around after that, right? Got MBAs, got JDs, got PhDs in history, right? We would be able to tell ourselves, on average, how much more do we expect you to earn if you spend an extra year in school? Now, this tool here is a linear regression. All it is a way of describing the relationship, the observed relationship from data between two different things, right? Two observed things. In this case, a person's earnings and a person's years of education. There's a couple important pieces of this. I'm going to rebuild this one piece at a time. We've got essentially two sources of data here. Earnings for person I is what we'll call our dependent variable. This is essentially the real data that we're trying to guess with our regression. Then on the other side, right, we have years of education. We'll call this our independent variable. These two things are the only real information or real data anywhere in our regression. The rest of the regression is an intellectual construct that we build in order to understand the relationship between these two things. So our A and our B, right? We said we've got A plus B times years of education. These are regression coefficients. These are values that we'll choose, or the regression will choose, in order to make our guess of how much you earn as close as possible to the earnings you get. Together, this whole piece here is our guess. That's how much we expect you to earn based on the years of education that you have. What's left over is our error term, right? That's the amount that our guess is wrong for each individual person. So the basic game here when we're doing a regression is we're picking A's and B's to guess as effectively as possible how much you earn based on how long you spend in education. What this B is therefore going to represent, the change in our guess, given that we learned that you spent an additional year in education. So in this case, right, if we've got basically high school grads earning $30,000, college grads earning $70,000, we would say that the change in earnings with each year of education is going to be $10,000. We would estimate a beta equal to $10,000. Okay, great. Okay, so let's say when we do our regression, right, we look at the average relationship between years of education and earnings. We find that our best guess about how much you earn should be $10,000 higher for every year that you're in school, right? So if we know that you've been in school 1 year longer than me, we don't know anything else about either of us, we're going to guess that you earn $10,000 more than I do. Is that enough to tell us that staying in school for an extra year would increase a person's earnings by $10,000? In other words, can we conclude from this regression anything about the effect of education on a person's earnings? I want you to think about it for a second. So I'm going to argue no, right? Because all this is telling us is an observed relationship, right? A correlation between two variables. You might have heard correlation doesn't equal causation, right? Doesn't imply causation. We can have reverse causality, right? In general, if we just do a regression between any two things, we could have reverse causality, right? If I regressed the purchase price of a person's car on their income, I would see a positive correlation. That would not tell me that I can make myself rich by buying a Lamborghini, right? Because the causation goes the other way. Richer people have more money to spend on cars. I might also, right, if I just see a correlation, might be due to a third factor, right, causing both things. So an example that I really like, if you regress pirate attacks per year against average global temperatures from about the year 1000 to now, 1000 AD to now, you'll see a strong negative correlation. It would be foolish to conclude from this that pirate attacks cause temperatures to fall. It would also be foolish to conclude that pirates like cold weather. It's much more likely to conclude that the rise of industrial civilization both made it more dangerous to be a pirate, right, reduced the amount of piracy, and also caused global warming, right, increased global temperatures. Great, right? So we can't really conclude anything just by seeing this observed relationship. But that doesn't necessarily mean that we just have to throw out this whole framework, right? It doesn't tell us that this can't tell us anything about causality. What it means is we just have to be very thoughtful about why there might be a relationship between earnings and education, what parts of that relationship are an effective education on earnings, and what parts of that relationship are not an effective education on earnings, right? Are equivalent to industrial civilization and pirate attacks. Wonderful. So let's think about all the reasons we might think that someone's education might be related to their earnings, right? So one thing, right, one argument you might make, expect people who spend more time in school to earn more money because they learned useful stuff, right? School helped them become smarter, right? Become more useful. Teaches useful stuff. I might want to throw in here something like, in addition to teaching useful stuff, right, helps you make good connections, right? And it proves to people that you're smart and hardworking, right? You get a credential that says, hey, look, I stuck around for 4 years in college. Why else might we think that there's going to be a relationship between education and earnings? Well, you might also think, I might argue, right, maybe people who stay in school longer are people who are more intellectually curious, are better at school, right, get better grades, and all of those sorts of things, right, curiosity, good grades, maybe hard work, ability to do all your homework diligently every night. All those things also help you be a better employee in the types of jobs that pay a lot of money, right? So we might say educated people are better at school and at work, right? Because they're smart, they're hardworking, they're diligent, all this stuff. On top of this, you might argue, I think this might be true, that people tend to stay in school longer when they come from families that have more resources, more connections, right, and generally greater capacity to help their kids, right? If you've got parents who can help you pay tuition, that's going to make it more likely that you stick around in school. If you've got parents who can help you with your homework, they're probably also going to be able to help you edit your resume, help you get, prepare for your job interviews, all this sort of stuff, right? So come from people have richer parents, I'll just say. And finally, I think this is important for those of us in college, right, who pat ourselves on the back to remember, could be that people stay in school just because they're really bad at working, right? They're bad at manual labor. So it could be that the fourth thing here is that educated people are klutzes, right? Right? If you've got the skills to become an Instagram influencer straight out of high school, maybe you don't bother with college. Right? If you've got the skills to become a plumber, maybe that sounds more interesting to you, you go to work right away. So maybe we'd actually expect that if not for school, the educated people would actually earn less than the less educated people. Great. So if we wanted to know, right, so the important thing to point out is, if all of these factors are at play, right, all of these are true statements about the world, then this $10,000 is going to reflect all of this, right? It's going to reflect the skills, connections, credentials that you got from going to school. It's also going to reflect the innate abilities that led you to stay in school. It's going to reflect the social advantages that you got that helped you stay in school. And it's going to reflect the innate disadvantages and incapabilities that kept you stuck in school when other people were doing other stuff with their lives, right? And so if we wanted to know what's the effect of education on earnings, we'd have to somehow strip away all this other stuff that doesn't change when you go to school, right? Of all these factors, only factor one is actually going to change for a particular person if they spend an extra year in school. So how can we change our regression here in order to reduce the influence of these factors, right, these correlational factors, but preserve the influence of this causal factor? What might we do? Well, remember, all the regression is doing is it's telling us our best guess about your earnings on the basis of the information that we give the regression, right? Which in this case is your years of school. It's your guess. So if we want our coefficient here, our coefficient on years, to not reflect this other stuff, we need to give the regression more information, right, so that we don't have to make assumptions about, for example, how good you are at school based on how long you stuck around. So let's imagine we did a regression where we said earnings equals A plus B1 times years of education plus B2 times, let's say, your SAT score, right? Right, or your GPA, or some indication of how good you are at school. So now, what's our beta going to tell us, our beta 1? Now, our beta 1 is going to tell us how much more we expect you to earn if we see that you spent an extra year in school, but we already knew your SAT score that you got in high school, right? So without this, Knowing that you spent an extra year in school is going to make us think, oh, I bet that person got a high SAT score. Now we don't have to guess, right? We already have that information. So our guess is just going to tell us the effect of beta 1 on our guess about how much you earn is just going to reflect the aspect of years of education that doesn't include your SAT score. This is going to tell us how much more we expect you to earn when you have one extra year of education if we already know your SAT score, right? This is basically going to tell us how much our guess changes with this additional piece of information. Because now this whole thing here is our best guess. We're going to call this a control variable. Because essentially we're going to say, we're going to take some factors of the people that we're looking at and hold them constant, right? Keep them under our control, account for them. And by adding control variables that take into account all these various ways that educated people and less educated people might be different from each other, we can eventually leave ourselves with only the actual effect of school reflected in beta 1, if we control for enough stuff. So one last thing I want to leave you with, and then we're going to move on from regressions. Given what I just said, should we control for everything, ideally? Right, if we wanted to capture the true effect of going to school on a person's earnings, is there ever a disadvantage of adding more and more and more information to this regression? In particular, I want you to think about what would happen if I added, let's say, an indicator to the regression for what kind of job you get, right? So I could say earnings is going to be A plus B1 times years of education plus B2 times, let's say, whether you work in a professional occupation. Is this going to help us identify the effect of education on earnings or not? So I'm going to argue this is actually going to hurt us. This is going to make our regression worse at capturing the causal effect. And the reason for that is, what our beta 1 is going to tell us now is how much more we expect you to earn, right? How much our guess changes. If we see that you spend an extra year in school, if we already knew whether or not you had a professional job. The problem with this, though, is that one of the ways we expect schooling to actually change things for a person who spends an extra year in school is that we think that it's going to help them get a better job, right? Get a professional job. So the relationship between years of education and earnings, not accounting for the effect of earnings on jobs, is going to be an underestimate of the real effect of education on earnings, right? So this here, I'm going to call a bad control or a mechanism. Because a change in the kind of jobs you get is part of the reason, the way that education affects earnings, controlling for that is actually going to take away some of the real effect that education has on earnings. Another way to think about this, another way to understand this, is to think, let's say that instead of just controlling for what job we had, we also controlled for some measure of your critical thinking skills. We controlled for the number of LinkedIn connections you have, right? We controlled for your self-esteem, right? We controlled for every possible way that we think that schooling is going to affect someone's earnings. And we saw that after controlling for all that stuff, right, knowing how many years someone spent in school doesn't give us any additional information that helps us guess their earnings. We would not want to conclude from that education doesn't affect earnings, right? What we want to conclude from that is that the reason education affects earnings is because it affects what job you get, your critical thinking skills, your LinkedIn connections, et cetera, et cetera, et cetera. Okay, wonderful. So punchline here, right? All the regression is ever going to do is just describe the data to you, right? It's just going to tell you how your guess about the dependent variable depends on your independent variables. In order to understand how that guess informs you about causal relationships, right, relationships of cause and effect, we have to have an underlying understanding of what we think is driving relationships between two variables, and control for confounders, not for mechanisms. Wonderful.